more than integration. Our next generation asset management portfolio consists of 4 key products. The first product is Asset Intelligence Network. The second product is Asset Strategy and Performance Management. The third product is Predictive Maintenance and Service. And the fourth one is Predictive Engineering Insights. So all these 4 products are cloud products that really help our customers in through their digital transformation journey in asset management. This is a suite of products that SAP has, and predictive engineering is a key pillar to this suite.
So the Asset Central is the central component of the digital core, and that means the register of asset data, correct? All the asset information shared amongst the different components.
That is right. Asset Core remains the central repository of all assets for a variety of applications. So if you're using, let us say, application Asset Intelligence Network, then you move on to Predictive Engineering Insights. You don't have to redo the entire master data because everything is integrated with Asset Core. You can easily start because there is just one repository of assets.
Regarding SAP Predictive Engineering Insights and the fact that customers are digitizing their assets, what are the low-hanging fruits that customers should aim for when they initially embark on the journey of digitizing their assets?
Back again to what I said, the users, customers, any owner of assets is faced with almost exponentially growing chunk or stream of signals from their assets. So their assets is like yelling all these kinds of messages in all these different kinds of languages. And it's becoming a rapidly increasing problem to understand what to do with all these signals. So I think in general, what we can do is make sense out of these signals, reduce this flow of information until make it legible and reduce the volume so that it's possible to take action in a better way than now. This is the general thing. If somebody is faced with almost inability to act because it's not possible to organize all these kinds of observations, we can simplify it using a model-based approach. And this model-based approach may be used for simple alerting. There have been some incidents now on structures falling down, like the event in Italy. These events are possible to detect if it's done in the proper way, but it needs to be done in a proper way. Signals need to be translated into something that humans can understand. This is what I think is, in general, the lowest hanging fruit. Simply make sense out of all this information and then implement fairly simple alerting or simple actions, or even give the engineers that work with these assets new instruments to understand the behavior of what is going on with their assets.
Just to add to that, I believe almost everything at the moment is a low-hanging fruit because we are very much in the beginning of tomorrow, so to say. A beginning of a world as we would know it 5 years from now is going to be very different from the way things are being done now. I think most of asset monitoring is very rudimentary, and we see many customers trying to do experimentation with a wide variety of use cases. The way technologies are converging, including cloud, big data, engineering simulation, and the asset management portfolio that we talked about, there is the convergence of all these together at this point of time is going to result in a completely new way of monitoring assets than we ever could imagine. So I think this could be applied to almost any kind of asset categories, and I do believe you can deliver tremendous value. I think 5 to 10 years from now, I would assume that people would not be able to imagine not having these kind of sophisticated methodologies to monitor assets. This would just become the new normal.
So if customers want to now start with this technology, how should they go about building the digital twin? How exactly are the relationships between SAP, FEDEM, ANSYS? Will SAP be the single point of contact, or the customer has to collaborate with the manufacturer of the asset and ANSYS? How can they build the digital twin?
From an interaction model, the product is being sold by SAP, so the customer would interact with SAP. And then we would engage our partner together for their expertise to ensure that we deliver the value from the product. So the primary point of engagement is SAP for the customer. So regarding your second question, do they have to go to the manufacturer? I think this question has been raised a couple of times, that will the manufacturer share the designs? Will they share the model information? We have seen several cases where there has been no hesitation for a customer to be able to approach their manufacturers. There are several reasons for it. Maybe Arnulf, maybe you can provide some details on the reduce order model discussion that we had yesterday.
There is a legitimate concern from manufacturers regarding the production or the concept of digital twins, because it implies that information about the product is transferred to somebody, whether that is SAP who hosts a model or the customer who can do something with it. And by doing so, it's the further concern is then that the IP will leak together with this model. Most of this is related to geometric information, material properties, details in the control system, mechanisms, how they work. And that is not necessarily needed in producing a digital twin. In FEDEM, this product may be reduced to a mathematical representation, a set of matrices. No geometry is in reality needed. And in ANSYS, this system may be reduced to runtime and a program, a reduced order model running like a program, where all the IP sensitive stuff is either left out or is embedded in code. In one sense, it's a black box that prohibits reverse engineering of the product, while at the same time, its main behavior is open to the user. So from our perspective, it's a win-win.
So basically, you get most of the data for the modeling, you are able to get it directly from the customer and the manufacturer, correct?
In most cases now, with modern, with assets built for industrial use or any use now, you will have some sort of CAD model to start with. And this CAD model is the origin of the digital twin. But it will then be manipulated so that only the relevant information is taken out. And this relevant information may not be that IP sensitive. In new build or in systems that come online now, it will come from the manufacturer. On the old system, one needs maybe to engineer it or to just represent it using drawings and knowledge about material properties. It's a different story. But more and more, the information will already be residing some way or another with the manufacturer.
So just to specify, at the moment, all the signals come from the sensors, or are there any other kinds of signals that are used? Does it all come from the sensors?
It's an important question. I think that we're not sensors, are simply sources of information. And of course, there are other sources of information. There are control systems that already pick up signals or have information about the operational condition. This is something that will be used in a predictive engineering insights context. There may be information from outside sources like the weather, or like we have been looking into satellite information or traffic information in order to understand the responses in bridges. Sensors are simply one main source that is needed to understand the physical behavior of a thing, but to make sense out of it, one will gradually integrate more and more information from various sources to refine further and provide deeper insights and more knowledge out of the insights. And the ultimate goal of the whole thing, we're often talking about applications, but the ultimate goal of the digital twin as it started was simply to go back to what Vatsan said, create a bridge between the physical world and the digital. And in order to do that, the digital world, the more deep insight it has into to the physical world, the more it is able to make sense out of it and produce actions based on this insight. A long answer to your short question. There are definitely more sources than sensors, and they will gradually come online, and we've already started working on that.
That sounds very, very interesting. My last question would be, what are some of the planned innovations for SAP Predictive Engineering Insights? And what is the product roadmap for the next few quarters?
A lot of focus at the moment is completing the embedding of ANSYS runtime into the PEI stack. So that is pretty much a big chunk of our focus. We are also delivering new applications for vibration analysis, which is not completely focused on digital twin, but physics-based analysis of vibration, which includes mostly frequency domain. And in addition, some of the research work that we are doing, a lot of it is focused on new use cases that we have, some of which perhaps this is not directly as a part of the roadmap, but these are use cases because the product development has multiple things. One is, what are the things that we are actually have tested and now we can productize? But prior to that, we do several things to make sure that the ideas that we have for productization is being tested and is validated. And one of the examples that I can give you is what Arnulf is leading in the case of monitoring of bridges. And this is not being productized. It's not a concrete part of the roadmap, but this is still being validated. So from a roadmap perspective, if I have to give you, I think some of the things that we're doing at the moment, which is planned for the November release, is vibration analyses with frequency spectrums and spectrograms, embedding of the digital twin runtime, alert creation based on frequency spectrum envelopes, and of course integration that we keep doing integration with the Asset Central and the asset portfolio at SAP. Following that, in 2019 February, we are planning to further embed the next round of ANSYS digital twin deployment for condition monitoring. We plan also to have frequency domain failure mode analysis in February 2019, enhanced integration with Asset Central with indicators, and the integration of SAP IoT services for data ingestion. And of course, we also want to plan a common launch pad with the Asset Central by February. And following that, some of the things we are planning in May is, of course, hybrid time and frequency domain analysis, modal response analysis, root cause analysis, and of course, combined scenarios together with SAP Predictive Maintenance and Service for alerts.
I'd like to thank you very much for your time.
That's all for today's episode. Visit gentacle.com to join the conversation and read the interview blog. We are also on LinkedIn and Twitter @Gentacle. If you enjoyed this episode, please make sure to subscribe and consider leaving us a 5-star review on Apple Podcasts, Google Podcasts, or wherever you get your podcasts. Thanks for listening. Until next time.